right, here's our explanation for 19. I'm going to go really quickly. If you need to slow it down, do so with the YouTube button. Here we go. We're asked to find the time. Time is only dependent on the vertical information. We know that in the vertical direction we have an acceleration of g. I'm making a positive g because down is my positive direction. I'm going to use the second formula, which I think you guys should always use if you're trying to find the time of a horizontally launched projectile. Since it's horizontally launched, the velocity in the y direction originally is 0. Okay, so that makes that go away. I'm going to call my initial position 0. That makes that go away. So then I have this formula, y equals 1/2 at squared. I can solve for time. Multiply both sides by 2. Makes that go away. Divide both sides by a. Makes that go away. Take the square root, and we'll get t equal the square root of 2y divided by a, which by the way was g, right? Because we're in free fall. Substitute our numbers in here. We'll get 2 times 1.5 meters divided by 10 meters per second squared. And then we'll take the square root of that whole quantity. That'll be our time. And our time will end up being approximately 0.55 seconds. I memorized that. I'm not that good. If you would just drop this thing, it would have the same amount of time. We want to know how fast it was going, or the horizontal component of the velocity as it flies through the air. Remember, the horizontal velocity does not change. So whatever it started with, that's what it's going to have at the time of impact or the time it hits the ground. It actually asks us for the velocity on the tabletop. But if you remember from your lab the other day, across a flat level surface, tabletop, your marble is not going to change its speed. So I really just need to know how fast is it moving horizontally. Well, I can do that by using the fact that it went 0.7 meters in 0.55 seconds. So I'm going to go back to that second equation again. In the x direction, constant velocity, so there is no acceleration. Boom, that goes away. I'm going to call my initial position in the x direction 0. That also goes away. So I've got the speed in the x direction times the time equals my final position. And so I'll just divide by t to get my speed. Oops. That looks like an x, doesn't it? Just substitute 0.7 meters in 0.55 seconds equals my speed in the x direction. And that's about 1.27 meters per second. Okay, well, it's the same throughout the air, it's the same at impact. That horizontal velocity will not change. All right, so now we're looking for the vertical velocity on impact. Well, we do know that the vertical velocity is changing at this rate, the rate of g. So if I want to know the vertical velocity at any point, I will just use my first formula. That's 0, right, because it's horizontally launched. So v sub y would equal 10 meters per second squared for the 0.55 seconds we already found. So that's 5.5 meters per second. One of these seconds cancels out. Also remember, I didn't say negative because I defined downwards as my positive direction. All right, now when it's asking you for the F and G is for the velocity of the impact, they don't want to know just the vertical velocity or the horizontal velocity, right? It's moving sideways at 1.27 meters per second. It's also moving straight down at 5.5 meters per second. Well, the actual velocity I could find if I made a little rectangle out of that and then drew the diagonal. that red vector is the overall velocity. That overall velocity can be found by the square root of my two component velocities. So I'm not sure what that is. I'm sure you can handle a calculator, okay? And then the angle, right? I need to know how far below the horizontal it is. So if I want that angle, I have to apply some trigonometry. I'm going to use the opposite side over the adjacent side. That is the tangent function. So if I take the inverse tangent of that, I will get that many degrees. Your answer should be this many meters per second that you'll get from here at this many degrees below horizontal. Stay tuned for number 20.